Hey, welcome back to part 2 of our lesson 4 logarithmic functions video. We are converting from log to exponent form and back, and we're looking at example 5 on this one. So we are not finding the inverse like we did the last example. We're just simply converting it to the different form, and we don't have to isolate x or isolate y, anything like that. So if you look at this, you go, okay, I have a log. I need to get to exponential form. How do I undo or get rid of a log? I do the inverse operation, which is exponents. So I will exponent, if you like, change both sides or change it to exponential form. Another way to write that. So now I would have just x equals 7 to the exponent of 4. That's right. Why I'm writing the 7 kind of down and to the left is to make it look more like a power, right? So it's 7 to the exponent of 4. All right, here I want to get rid of the log again. So we exponent both sides. Now why did I choose 5? Because that's the base on the log. How do you undo a log? Base 5. You go 5 to the exponent, log base 5. So now that becomes 15 equals 5 to the exponent y. All right, same thing here. We're going to get rid of the log by doing the inverse. Okay, write it in an exponential form. T to the exponent m equals b. Oh, now d, we hit a bit of a snag because this 4 is kind of in the way. If I wrote a b there, the 4 would be in the way. So we have to get rid of that 4 first. We are going to divide both sides by 4. Okay, because it's just 4 times log base b of 6. And now we have 5/4 equals log base b of 6. And now I can get rid of the log. So I'm going to change it to exponential form. And that then would become b to the 5/4 equals 6. And there we go. Awesome. Okay, example number 6. We're going to convert each of these from exponential form. Notice we've got a power on each one of these, to log form. So if we want logs, we're going to have to log both sides. The question is, what base are you going to choose for your log? Well, the base you want to choose to make things a little simpler would be base 4, because that's the base on our power. But really, you could choose anything as your base. We're just choosing base 4, so that now this could simplify. Log base 4 of 4 cubed, as long as the base on the log and the base on the power are the same, it equals the exponent. I said that really fast, didn't I? Okay, so what else should we do? Let's do this one. Okay, actually, why don't you guys try B and C, and then we'll check back, and we'll do D together. Okay, so pause your video and give those a try. Okay, so hopefully on that one you got, for B, -3 equals log base 2 of 1/8. And for C, D equals log base E of F. That's an interesting one with all those variables. Okay, let's try D. Now, D I know looks worse, right? But focus on, just try and pretend this 2x plus 4 is just one thing, okay? Focus on taking the log of both sides, okay? Because we want to change it to log form. Then, where's your power? The thing that had the exponent on it? Right here. What's the base on that power? It's base A. So let's write the logs as base A. So now we would have log base A of 2x plus 4. And the right-hand side would equal just 5, because the base on the log, base on the power are the same, so therefore the log is the exponent. There we go. Let's take a look at the next page. Good job, you guys. Example 7 is very much like a test question, okay? And I'm going to write that down because you know how test questions tend to be a little bit harder than the regular standard questions. Okay, so this would be a little more challenging. Calculate the value of t if log base 2 of x equals 3 and log base 2 of t equals x. Lots of stuff going on. Focus on what they're asking for. Value of t, where's t? T is here, okay? So I want to get at that t. How would I do that? Well, I want to get rid of the log then, don't I? So let's get rid of the log by doing the exponential form. So take the exponent on both sides and we'll have t equals 2 to the x. Okay, well that's good, except they want the value, which means it has to be a number, and we've got 2 to the exponent of x. So where was x? X was here, wasn't it? Okay, how about if we see if we can get x by itself here? So we have log base 2 of x equals 3, let's get rid of the log to get at the x by exponenting, bad grammar, both sides, x equals 2 to the exponent 3, which we know to be 8, right? 2 times 2 times 2. Now, back to here, let's put 8 in for x, and now we have 2 to the 8th, which I do believe is equal to 128. No, yeah, it is. Yeah, 128. Okay. No, it isn't. It's 256. Sorry. That's what I get for trying to do that in my head. 256. All right. There we go. Okay, sorry about that. All right, let's take a look at this is really just more of the same. It's just there's an extra little complication with examples 8 and 9, and that is that when we go to change it from exponent to log form, there's something in the way. Okay, so if you look, y equals 2 times 2 times 3 to the x, our power is really, it's got a 2 in front of it. So we need to isolate our power first to change it to log form. So we are going to divide by 2, and we'll have that. Then we can log both sides, okay, and the base we're going to choose for our log would be the same base as our power, so 3, okay, and that means that on the right-hand side now would just be x, the exponent, and we'd have log base 3 of y over 2. And that would be our final answer for that one. Okay, we probably don't need to do too many of those. Maybe we'll do D as well, and then we'll look at the next example. So here, again, we want to isolate the power. So we want to get rid of 3/2. Now we could do that in 2 steps, might be a little bit easier. If we first multiply both sides by 2, that would get rid of the sort of 3 over 2 part. And then if we divide both sides by 3, 2y over 3, and there we go. Now we log both sides, 2y over 3 inside the log this side. And what base should we choose on the log? Same base as the power, which is 10. Now, I don't have to write base 10. Oh, that gets into it on the next page. So we'll write base 10 on this one. Okay, and then we'll have log base 10 of 2y over 3 equals x. And there we go. Okay, example number 9. Change each of the following from log to exponent form. So, same idea. These ones are fairly straightforward. We'll maybe do the last two, C and D. We want to get rid of the log, so we are going to exponent to both sides. And we have 7y equals 5 to the x. We're going to isolate y, because that's how they wanted it, by dividing both sides by 7. Now, if we divide both sides by 7, like this, you don't really want to write it like 5 to the x over 7, although not really incorrect, but it's better to have it like they show it here as some number in front of your exponential function. So what would be in front? Well, there's sort of like a hidden 1 in front of the 5, so we're going to call that 1 over 7. And let me just write a 1 in red so you can see that. So it's like 1 over 7 and then 5 to the x. Now we should probably put something in brackets just so that it doesn't look cluttered there with the 1/7. Okay, so let's do the same thing with the last one here. E to the log e, gone, and now we're down to y equals 5 equals e to the x. We're going to multiply both sides by 5 to get rid of that 5 being divided by y, and we'll have 5 e to the x. And there we go. All right, good job. That finishes off this lesson, I do believe. Hang on, let me check. Yes, it does. So we are going to also have lesson 5 included in conjunction with this one. Hopefully we'll do that in one video. So we'll see you in lesson 5. Thanks for listening.